Last set of AP practice problems to go over, so let's take a look at these, see how you did. Again, with these being multiple choice, no calculator, on average 2 minutes per problem. Number one, there's a couple ways to do this. You could quickly go through and maybe take the derivative of each one and see which one comes out to be cosine of 3x, or we could just simply work our way through this to find the antiderivative. So you could use substitution here, but we've done this enough without it. So as we walk through this, we know the antiderivative. So if we took the derivative of sine, we would get cosine. So we're going to look at sine, and we still need to have this 3x. But if we took this derivative, we would get cosine of 3x times 3. We'd have to get rid of that extra factor of 3, so we would need a 1/3 out in front of it. And then plus our constant of integration, so that's giving us c. Like I said, you could also do substitution, let u equal 3x, and then go from there. Number two, so if you notice very carefully, this is as x is approaching 0. So if we use direct substitution here, we would get 0 over 0. So this is a great application of L'Hopital's rule. We don't divide by the largest power of x here. That would be if x was going to infinity. So in this case, we want to use L'Hopital's rule. And right now we have an indeterminate form of 0 over 0. So all we have to do is keep taking the derivative until we get something that changes from this form. Now, because this is a multiple choice question, we don't have to be too picky about the notation. So if I just were to take the derivative of the numerator, this would give me a 12x to the 5th plus 18x squared over 20x to the 4th plus 9x squared. That's not doing us any good. Still 0 over 0. So we'll do this again. We'll get 60x to the 4th plus 36x over 80x cubed plus 18x. We still get 0 over 0. So we'll do this one more time. Now again, if this were a free response question, you want to keep the limit notation in front. Like I said, because it is multiple choice, they're not looking at our work, so we could go through this a little quicker. Taking the derivative one more time, we will get 240x cubed plus 36 over 240x squared plus 18. So now if we were to substitute in 0, these two terms would be gone. We're left with 36 over 18, which is 2. Okay, looking at number 3, we're given a piecewise function above. For what value of k, if any, is f continuous? So when a function is continuous, that means f of 2 exists. The left-hand limit is equal to the right-hand limit at x equals 2. And the limit as x approaches 2 of our function is equal to f of 2. So that pretty much gives us the go-ahead to set these two equal to each other when x is equal to 2. So we would get x squared minus 3x plus 9. The left-hand limit here is going to equal the right-hand limit. And then f of 2 exists, so I could go ahead and substitute a 2 in here. So I'm going to get a 4 minus 6 plus 9 is going to equal a 2k plus 1. So this will give me negative 2 plus 9. So we'll get a 7 equals 2k plus 1. 6 would equal 2k. So k is going to equal 3. All right, for number 4, we're just taking the derivative carefully here. So we could think of f of x as cosine of 4x, that whole quantity cubed. So then our derivative, careful use of the chain rule. First we bring that 3 down, then it's times cosine of 4x squared times the derivative of cosine, so it becomes negative sine of 4x, then times the derivative of the innermost part, which is 4. So now if we multiply, looking at our answers here, this is going to give us a negative 12 times cosine square of 4x times sine of 4x. And that was B. Okay, for number 5, we're looking for a relative min of this function. So that means our first step is to take the derivative. That'll give us a 6x squared minus 6x minus 12. It's never undefined, so let's set this equal to 0. We want to factor out of 6. That'll leave us with x squared minus x minus 2. And then this will factor into an x minus 2, x plus 1. So our critical numbers are negative 1 and 2. So we'll make a number line. Still going to label it, but again, because it's multiple choice, we're not going to miss points if we don't label it. So we'll have a -1, we'll have a 2. I want to pick some values here. So let's say we're doing a -2. We have positive, that'll be negative, negative, so we'll get a positive here. Let's say we pick 0. We have +6, this will be negative and positive, so we'll get a negative. Let's say we pick 4, positive, positive, positive. So if we're going, F is going from increasing to decreasing, back to increasing. So we have a relative min at x equals 2. All right, for number 6, let f be the function given by, we're actually having two factors here. Which of the following is an equation for the line tangent to the graph of f at the point where x is equal to 1? So we need to use a product rule. We want to find f prime of x, which is the slope of our tangent line. So uv prime will become this quantity to the fifth. V prime will just give us a 1, plus we'll have V, and we have to carefully use the chain rule, times 5 times the quantity 2x minus 1 to the fourth times 2. So f prime of x, we'll just make this look a little nicer. We just have 2x minus 1 to the fifth, say plus 10 times the quantity x plus 1 times the quantity 2x minus 1 to the fourth. So now, for figuring this out at x equals 1, f prime of 1, that's going to give us 2 minus 1, so that's just 1, plus 10 times 2, so we just write that as 20, times, and this will just give us a 1. So we're going to get a 21 here. So f prime of 1 is equal to 21. And then we need our points. Now we want to find f of 1. So here we're going to get a 1 times 1 plus 1, so we're going to get a 2. So we have the point 1 comma 2. So then our equation in point slope form will start with y minus 2 is going to equal 21 times the quantity x minus 1. Nothing's in that form, so we need to solve for y. 21x minus 21 plus 2 gives us y equals 21x minus 19. That was B. All right, for number 7, we're going to use substitution here. We're going to let u equal square root of x. Now again, we could do this, or you could just go through and take the derivative of each one here and see which one gives you e to the radical x over radical x. But this is good practice with u substitution. So this is going to become, this is x to the 1/2, and that always turns into 1 over 2 radical x dx, because we'll get 1/2 times x to the negative 1/2, and we simplify it here. So then dx is just going to become 2 radical x du. So now we have the integral of e to the u over radical x times 2 radical x du. So we'll put the 2 out in front. Radical x's divide out, and we have e to the u du. So now this becomes 2. Antiderivative of e to the u is just e to the u plus c. Well, u is radical x, so we get 2e to the radical x plus c, and that's A. Number 8, we're given this table above. The function f is continuous on a closed interval and has the values given in the table above. The trapezoidal approximation is this integral here, found with 3 subintervals of equal length, is going to be 52. What is the value of k? So we could just know that 52 is going to equal, now notice it's 0 to 2, 2 to 4, so we could just say that the same distances here. 1/2, our height every single time would be 2. Trapezoidal rule means we just take the 4 once, and then we double everything in the middle, so it's going to become plus 2k plus 2 times 8 is 16, and then we just have one of the last values, which is plus 12. So we get 52, half of 2 is just 1. So we're going to get 4 plus 16 plus 12 will give us 32 plus 2k. So that's 20 is equal to 2k, and k is equal to 10. Number 9, a particle moves along the x-axis so that at any time t greater than 0, its velocity is given by this function here. If the particle is at position x equals 7 at time t equals 1, what is the position of the particle at time t equals 2? So all we have to do is know that v of t is equal, we'll use x of t. So to work backwards, we're just going to take the antiderivative. So x of t is going to be the integral of v of t dt. Again, because it's multiple choice, you don't have to write that out. But this will give us now, we'll take the antiderivative of this, which become 4t minus 6t cubed over 3, which we could simplify, and then plus c. So x of t is equal to 4t minus 2t cubed plus c. So right now this is like our initial condition. So we'll say that x of t, which would be 7, is going to equal, t is going to be 1, so we'll have 4 minus 2 plus c. So that's 2, 7 minus 2 will give us 5 for c. So now we have x of t is going to equal 4t minus 2t cubed plus 5. And now we could find x of 2. That'll give us an 8. That'll give us negative 16 plus 5. So that's negative 8 plus 5 is negative 3c. All right, number 10, the function f is given right here. The figure above shows a portion of the graph of f. Which of the following could be the values of the constants a and b? Again, because this is multiple choice, we don't really have to be particular with our work, but I do want to show you where we're getting everything from. If you look at the graph, what's going to help us here are the horizontal and vertical asymptotes. So we have a horizontal asymptote of y equals 3, vertical asymptote x equals 2. Let's start with the vertical asymptote. That's always the easiest. That happens when the denominator is equal to 0. So we'll go ahead and do that. Our denominator is x squared plus b. What's going to make that equal to 0? So we know x is 2, so that's going to give us 4 plus b is equal to 0. So guess what? B is equal to negative 4. Take a look over here. We really don't have to do any more work, but I'll explain it. B equals negative 4 is the only answer here for D. Now the horizontal asymptote is going to help us out here. Notice the degrees of the numerator and denominator are the same. So that means if I took ax squared over x squared, I need to get a 3. So the x squares divide out, and that means a is equal to 3. So vertical asymptotes in this particular case, we would really take the limit as x goes to infinity of ax squared plus 12 over x squared plus b. And you could divide everything here by x squared. But again, if the degrees are the same, we're just dividing the coefficients. Number 11, what is the slope of the line tangent to the graph of this? That just means we want to find y prime at x equals 1. So y prime is going to equal, we have to use the quotient rule here, low d high, so we have x plus 1 times e to the negative x, then times negative 1. So that's low d high minus high, and then d low is just going to give us a 1 over low low. And then we'll say at x equals 1, y prime is going to equal, this will give us a 2 times a negative 1, so we get a negative 2 times e to the negative first, minus e to the negative first. All over this will give us 2 squared, which is 4. So now we could rewrite this as negative 2 over e minus 1 over e all over 4. We can combine these into one fraction. We get a negative 3 over e divided by 4. We could rewrite this multiplied by the reciprocal, which gives us negative 3 over 4e. That was b. All right, our last two. Here in number 12, we're given the derivative is equal to 2 over x. So f of x, so because this exponent is a 1, we can't use the power rule for antiderivatives. This involves, the antiderivative here would involve the natural log. So this becomes 2 times the natural log of the absolute value of x plus c. We have an initial condition here. So f of radical e is equal to 5. So we would get 5 is equal to 2 times the natural log. Square root of e is positive. I'm going to write this, though, as e to the 1/2 just to save some time, and then plus c. So this now becomes 5 is equal to 2 times 1/2 times the natural log of e plus c. Natural log of e is 1, so we just get 5 equals 1 plus c. 2 times 1/2 is also 1. So c is equal to 4. So now we have f of x is equal to 2 times the natural log of absolute value of x plus 4. Now they want us to find f of e. Well, that's equal to 2 times the natural log of e plus 4. Natural log of e is 1. 2 plus 4 will give us 6. So there's D. All right, now for 13, the last problem here, you would think use substitution, but the problem we run into here is if u is equal to x cubed plus 1, du is going to equal 3x squared dx, and we don't have another x squared here that's going to divide out, so this isn't going to work. Because it's only squared, we can actually expand this. So we don't have to use u substitution. It would not work in this case. So if we squared this quantity, we would get x to the 6 plus 2x cubed plus 1 dx. And then we would just take the antiderivative here. So we would get x to the 7th over 7 plus 2x to the 4th over 4 plus x plus c. Simplifying the middle, or the second term here, we would just get 1/2 x to the 4th plus x plus c. So that looks like that matches B.